Alright, this is Shane with Ozone Water. In this episode, we're going to go over some troubleshooting on our larger size Ozone Destructs. This includes the 50 CFM, 100, 200, and the 400 CFM Destructs. One's equipped with the magnehelic gauges showing the bed and the blower values. Just as an example, we have this one running in our shop. Now it doesn't have the in and the out plumbing plumbed in, so the numbers are not going to necessarily match what you'll see at your facility, but these are just examples to show you what, if you see a certain reaction of the magnehelic gauges, what you'd want to look for to diagnose that issue. So let me show you right now. Sorry if it's a little loud. Right now we have it running in normal condition. And our destruct value, I've made a little line here to show you what the normal location is for the destruct and the normal position of the needle on the blower. First issue we're going to demonstrate is if you have any blockage on the suction port where that leads up to the top of your contact tank. If that gets blocked, we're going to show the results on the magnehelic gauges if that occurs. Scott's going to plug that up now for us. Wait. Alright, so if that gets plugged, the destruct is going to go down because there's no flow across it. The blower is going to get higher because now it's trying to suck air that's not being provided by the top of the contact tank. So if the blower value goes up and the destruct value goes down, you'd want to be looking for a blockage in your incoming plumbing off the top of the tank. Now the next test we're going to do is if there's blockage on the discharge of the blower. So this would be the pipe that's leading out of the roof of your building or out of the wall for your off gas after it's been destroyed. It's just venting out. So if that gets plugged up, this will be the result of your magnehelic gauges. Okay. All right. So as you can see, in that case, both of them have gone down. There's no flow through the entire system, so there's no differential pressure across any of those ports. Now the one possibility is if you plumb the atmospheric pressure port into that off-gas pipe downstream somewhere, depending on where the blockage was in that off-gas pipe, you may see a different reading on that. We don't generally plumb those ourselves, so if you've done that, it'll be a different value. The next test we're going to do, which is a little trickier, we're going to pull off the top of the tank and we're going to block the destruct media so that you can see what your gauges will indicate if you've got media that's getting plugged up. Okay, so I've plugged up the media. Obviously this is an extreme case where I'm mostly plugging it all up. It's not usually going to be this dramatic, but in order to make an example out of it, you'll be able to see what the gauges do in an extreme case. Let me turn the blower back on and then we can watch the result of the gauges. So you can see the differential across the destruct, of course, has gone up because air can't flow through the media as freely. So that value is increased. In this example, the blower differential has also increased because it's having a harder time drawing the air through the system because there's a restriction that it's putting a higher differential across that. Now another thing that you might find if there's any blockage either in the media tank or if there's some blockage on the suction port. So you can see even that blower draws a lot of air through there. Even with that blockage in there, it's still sucking quite a bit of air through this. The function of this vacuum brake is to allow air to draw in if there's blockage in the media or in the off-gas plumbing to the tank. It's hard to demonstrate this on video. I'm gonna plug that up. But there's a slight suction on that. Scott's going to plug up the suction port now. And now, I mean, you hear that, but it's putting a high vacuum on my hand. All right, let me show you how the vacuum relief valve works. Some of our models have this relief valve on the top. This one's going on the side. In this case, I'm just going to unscrew it so I can show you. It is possible to do this with it still installed. You just have to pull this cap off. So the relief valve is basically a spring-loaded valve that you can adjust the spring tension on to determine how much pressure it takes to open the valve. I'm going to go ahead and pull off this cap. If it was mounted on the top of the tank, you could do all these adjustments just by pulling this cap off. When they're hanging off the side, it's a little trickier to get up underneath there and do it, so it just makes it easier. But when some of these are mounted on top of the tank, and you can do these from right here. But as you can see, there's a flathead screw notch in the top of this shaft, and then there's a 1/2-inch nut. And below that, there's a spring. So if you can see that, inside there is a spring, and when you turn the nut down on that shaft, it tightens the spring, and that's going to increase the amount of vacuum it takes to open the valve. So you have a couple options on how you can do it. As you can see, if I push on the side with the nut, the valve opens, and that's normally the vacuum in the system. The high vacuum is going to cause that to open. There is no specific torque spec for this, and we dial them in to a basic tension here, but again, that's with no plumbing on. So once it's installed in your facility with your plumbing installed, this tension may change, so you might have to make adjustments to this. Usually not, but you do want to be aware of that. In normal operation, when this is installed and the system is running normally and you put your hand over this, you want to feel just a very slight suction on that under normal conditions. That way we know it's just barely open. It isn't going to hurt anything to have a little bit of air. There's a little bit of a screen on here, obviously not fine screen, but that slight amount of air tells you that if there's any significant obstruction in the plumbing, that this is going to open and allow air to come in, so we don't put a high vacuum on the system and put extra wear and tear on things. So if you need to do that, there's two ways to do it. You can hold it with, you can get a deep 1/2-inch socket to go over that if you want, or you can hold it with a flathead screwdriver while you get a wrench inside of there. That's a little trickier, but if you're doing this with it installed, you kind of have to do it this way. You put your 1/2-inch wrench on there, and then you can put a flathead screwdriver on it, and then rotate the nut in or out, depending on how you need to adjust the sensitivity. If you have this off like I do, a 1/4-inch Allen key into the end of that will hold that in place. Now I can get my wrench or my deep socket and make adjustments to that nut. So just remember that in normal operation, and that's a good check to do when I'm at a site, I'll walk up to a Destruct that's running and I'll just put my hand over the top of that. Actually goes this way. And I just want to feel a very slight suction in normal operation. If I walk up and it's sucking on my hand extremely hard, I know there's an issue with the system that we need to address. That's how you adjust the vacuum relief valve. Maintenance on the media tank. There's a couple of things you want to be aware of. We already talked about whether this gets clumped up, and you need to periodically check that to make sure that it's loose and free. Another thing you want to check for is these screens can get blockage in them. Just from stuff in the air, it can plug up those holes on the screen. If that happens, it's going to cause a restriction. You'll see that indicated up on your MagnaHelix gauge. Now that one would be a little different scenario. That's not the same as blocking the media because the port isn't detecting it. So if this one starts getting plugged up, you're going to see both MagnaHelix are going to drop because your total gas flow through the system is going to drop. This example of the reaction to the MagnaHelix, we're trying to simulate a blocked screen on the suction port of the blower to show the reaction of the MagnaHelix in that condition. All right, we'll turn the Destruct back on and watch what the reaction of the MagnaHelix. So you can see on the Destruct we have a very low value. There is still some indication on the blower, but that will depend on how plugged up the screen is. So in general, both gauges are going to go down if that suction port for the blower gets blocked. So we mentioned debris various things plugging this up. One thing that can really cause this to plug up is if there's any moisture in here, which is also going to damage your media, but that also causes a lot of, it turns kind of basically into mud when this stuff gets wet. It absorbs a lot of water because it's so porous, but that can percolate up through the media and it gets lodged in these pores. So that's going to cause you to lose your gas flow, total gas flow through the system. So keep that clean. Also at the bottom of this media, which by the way in most of our ozone destructs, you're looking at a media level of 17 to 19 inches deep. So coming down the side of this, about 17 inches, there's going to be another platform and a screen. And that screen can also get plugged up with that media. So when this gets maintenance, or if you're noticing a decrease in flow, or the magnehelix are indicating that you perhaps have a plugged media bed, when you do check this, unfortunately you have to empty the whole media tank out to get to that bottom screen. That is a maintenance item that will need to be cleaned at certain intervals when you do a media change. So usually when you do a media change, you're going to clean all the screens and you're going to put an all new media in the system. We did talk about water in the bottom of the media tank, and there's a float. There is also, let's see if I can show it here, a drain. So if water ever gets into the bottom of the media tank and that float switch is triggered, there is a drain plug in the bottom of the media tank. You get a look at that over there on the side. So if there gets water, if you need to drain it, pull that plug out and you can get the water out of the tank. And on this drain, this is, I think I mentioned it earlier, but to reiterate, if the P-trap gets too full from water coming off the contact tank, it will drain to the drain right here out of this port. We do recommend a vacuum break, so we come out of this to a T, so that if this drain were to get plugged, it would not cause the P-trap to overflow and then blow water out into the media and through the blower. Thank you for watching this demonstration of our larger size ozone destructs. If you have any questions, as usual, feel free to call our offices at 480-421-2400, ask for tech support, or you can email us at info@ozonewatersystems.com. Thank you for watching.